All right, so we're picking up where we left off. Now we're going to look at how to graph a parabola if it happens to be in this format here, y equals ax squared plus c. So here's our example problem. Y equals negative 3x squared plus 2. A parabola in this form has a vertex at 0, comma, this is a c, so I'll just make that a little bigger here. And a is equal to negative 3, and c is equal to 2. So then our vertex is 0, 2. Choose two values of x on either side of x equals 0 to find the corresponding y values. Okay, so on Alex, you're going to need to plot 5 points on the parabola, and they're going to force you into plotting the vertex, 2 points to the left of the vertex, and 2 points to the right, so for a total of 5. Then you're going to click on the graph a function button. Okay, so in Alex, you're going to have to plot these 5 points. So let's start off with this format. I'm going to take this problem that we're going to work with, and I'm going to write it underneath this template. Okay, so we can see, what are they saying here? When they say a is equal to negative 3, well, negative 3 in front of the squared term is our a value, and c is equal to 2, right? So when you have a parabola, and a parabola, remember, is either going to face, I call this facing down, or it's going to face up. So let me make a little key here. This is facing up, face up. This is face down. I think my pen is leaking. Let me get a different one. Okay, and something else too that we can kind of put on our little key here is if your parabola is facing up, your vertex is right here, and it's called a minimum. So think about something dropping down and then hitting this vertex, bouncing off of it, and then bouncing back up. So this is the lowest point or the minimum, and it's the vertex. Sometimes it's referred to as the turning point. Okay, when you have one that faces down, your vertex is here. Okay, this is your maximum. Think about throwing a ball up in the air. It comes to a split second decision before it starts to fall back down, and that happens at the maximum or the vertex. It's also the turning point. Okay, something that I also think might be a good thing to write down, especially if you can use a piece of paper as like for notes, on your test, is when your a value is positive. So when your a value is positive, your parabola is going to face up. When your a value is equal to a negative, there's a negative like this one, it's going to face down like that. So that's a little trick to kind of help you figure out, like, well, how's this thing going to look? So if your a value is a positive number, then it's going to face up. If your a value is a negative number, like in this case, it's going to face down. Okay, they tell us that 0, comma c is the vertex. Okay, so that means 0, comma, what's our c value? 2 is our vertex. So we can get that graphed. So I'm going to go over and find a 0, 2 right here. Now, they want you to plot 5 points. So I'm going to make an XY chart, and I'm going to put my vertex in the center, 0 and 2, because they're asking us for 2 points to the left of the vertex. So that's going to be this way, and 2 points to the right. So that's going to be that way. So 2 points to the left would have X values of like -1 and -2. And 2 points to the right would have X values of like 1 and 2. So this is how I kind of set myself up here. So this is my vertex. And then I need to substitute in these different X values into this parabola equation and figure out what's the corresponding Y value so I can sketch this out with 5 points. So if I put a -2 in, let's see what the Y value would be. Y is equal to -3, because that's part of our formula here, or excuse me, our our parabola, the problem we've been given, we're going to put a -2 in for x. There's a square after it, and then we're going to add 2. So this is order of operations. So order of operations says you want to do your parentheses and exponents first. So this turns into -2 squared, which is -2 times -2, which is 4. 4 times -3 is -12, and -12 plus 2 gives us -10. We can do it again to put a -1 in for x this time. So I'm going to rewrite this out, but this time I'm going to substitute in a -1. So -1 squared is -1 times -1, which is 1. 1 times -3 is -3. -3 plus 2 gives us -1. We don't have to do the vertex. I mean, you could write it out if you wanted to. Y equals -3 times 0 squared plus 2. We know 0 squared is 0. 0 times -3 is 0. 0 plus 2 is 2. But you don't need to go through that if you don't want to. So I'm going to just write this out, this little equation, 2 more times. These are going to take, they're a little time consuming to do, but not impossible. We're going to put a 1 in for x. We're going to put a 2 in for x. So 1 squared is 1 times 1 is 1, times -3 is -3, plus 2 is -1. 2 squared is 4. 4 times -3 is -12. -12 plus 2 is -10. So you're going to start to see a pattern here. So take a look at this pattern. This might be helpful to you. So I'm not going to say anything else about the pattern. Just going to let you think about that pattern. And I'm going to get these sketched out here. So these points. So -1, -1 is here, and -210 is down here, and 1 -1 is here, and 2 -10 is here. Actually, it's over here. And then you're going to click on a graph a function button in ALEKS, and when you do that, it will draw your parabola through there. That's a mess up there. Okay, so something to notice when I just said a second ago, I'm not going to say much about this, but I want you to kind of see it, is that parabolas are symmetrical. So if this is a -1 here, it's going to be a +1 here, right? If this is over here is sitting at a -10, this is probably going to be sitting at a +10. So they have symmetry. So that might help you. They're symmetrical. That might help you with this little chart here. Okay, so that's how you should tackle parabolas that are in this format. Now, parabolas come in 2 different formats, and we're going to do an example of each coming right up. Okay, here's another way a parabola presents itself. I call this HK format. You'll see there's an H and a K in here. Graphing a parabola of the form y equals ax minus h squared plus k. So here's our problem. Y equals 3 times x minus 2 squared minus 7 is a parabola in this format. It has its vertex at HK. And here's my hint. Think opposite sign of H, no change on the sign for K. And I'll talk you through why I wrote these notes here. Choose 2 values of x on either side of x equals 0. Actually, I can cross this off here. Let's follow these directions. Plot 5 points on the parabola, the vertex, 2 points to the left and 2 points to the right. Then click on the graph a function button. Okay, let me write this out right underneath its formula here. Okay, so they told us that the vertex, remember the vertex is that turning point, whether it's here, maximum, or minimum, those are the vertex, is at HK. So here's your H, here's your K. So I say use the opposite sign of H. That's because in this format, there's a negative sign in front of the H. So if you put that negative with that negative, it's going to make that a +2. So the vertex is going to be +2. And then the formula for K has a plus sign in it. Plus sign doesn't change this. So we're just going to no change on sign for K. We're just going to make that -7. So the vertex is 2, -7. So whatever the H value is, all right, if it's negative, change it to positive. If this was a positive, change it to negative. Whatever your K is, just keep that sign, right? So if this was a +7, then that would be a +7. But because it's a -7, we're just going to leave it as a -7. So we're going to make a little chart. I'm going to put the vertex in the middle, just like I did on the last example. And then let's plot it. So 2, -7 will be over 2 down to -7. So let me put that on my screen here. So that's going to be my vertex. On the last example, I think I gave a hint that if your A value is equal to positive, your parabola is going to face up. If your A value is equal to a negative sign, it's going to face down. Okay. Our A value here is +3. Let me go up here and show you that. +3. So because it's a positive, we know this is going to face up. So it's going to be this one here. Okay, so we need to come up with two x values to the left. So that could be -1 and 0. And we need to have plot 2 points to the right of 2. So that might be 3 and 4. Okay. And then just like on the last one, the last example, you're just going to plug these numbers in. You don't have to redo the vertex, but you're going to plug these x values in to see what y is. So I'm going to rewrite out. See, that's a 3 here. So notice I put a 0 in for the x, a 0 went in for that x. It says, if you want me to tell you what y is, I need an x value. So we're going to put that x value in there. So let's do this. 0 minus 2 is -2. -2 squared is -2 times -2, which is 4. 4 times 3 is 12. 12 minus 7 is going to be 5. Let's do it again, putting a -1 in here. Okay, so I placed the -1 in for x. Order of operations, do your parentheses and exponents first. So -1 take away 2 is -3. -3 squared is -3 times -3, which is +9. Let's see here. 9 times 3 is going to be 27. I think I'm off track. Let me refocus myself. Hold on. All right, so after thinking about that for a minute, I'm not off track. It's just that I'm not going to be able to graph it. So -1 minus 2 is -3. -3 squared is -3 times -3, which is +9. 9 times 3 is 27. 27 minus 7 is 20. I'm just not going to be able to graph that point. Now the graph in Alex, it'll probably give you a big enough graph to graph it, but the ones that I kind of copy isn't going to allow me to probably graph that point. But that's okay. We'll get a look at the shape here with just 4 points. So I'm going to rewrite out this problem again, but this time I'm just going to do them both at the same time. So we know the 3 is like comes standard on the formula, or excuse me, on the practice problem. We substituted 3 and 4 in for x. You still have to -2 square and take away 7. Okay, now 3 minus 2 is 1. 1 squared is 1 times 1, which is 1. 1 times 3 is 3. 3 minus 7 is going to give us -4. And then 4 minus 2 is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 7 is going to be 5. All right, let's see how many of these we can actually get on this graph. So 0, 5 is going to be right here. And I can't do -120. It's like going to be somewhere up there. 3, -4 here, and 4, 5. All right, so hypothetically, it's going to come through the point there. It's going to come down. Oh, this looks terrible. It's going to bounce off here. It's going to come back up and do something like that. This looks terribly not symmetric. So my graphing skills probably could have been a little sharper on that. But hopefully you can find 5 points on your parabola, and then there's going to be something called a graph a function button that you can click on. And if it's right, it'll put a parabola right through all your points. So that's how to kind of deal with one written in HK format. Let's take a look at another one that's maybe written in one last way. Aha, there it is. Y equals x squared plus bx plus c. Okay, this is the last format you're going to see. The first one that we went through, let me put that back up here, was y equals, let's write these all out here, ax squared plus c. And remember your vertex was at 0c. The second one that we just looked at was that last one, which is y equals a x minus h squared plus k. And the vertex was at hk. And remember it was the opposite sign. And keep the same sign. Okay. And then this last one, we're going to add this last one into the mix. So this is a parabola written in what's called standard form. So let's take a peek. Y equals x squared minus 10x plus 20 is a parabola in this form, has an axis of symmetry as the line x equals negative b over 2a. Okay, so let's remember what kind of a line is x equals something, okay? So x equals something is going to be a vertical line. Let's see here. So this gives us a little hint on how we can try to find our vertex. Because axis of symmetry is going to be cutting. When they say axis of symmetry, that's going to cut the parabola directly in half. And if you take a parabola and cut it in half, like that, or one facing up like that, you're going to automatically find your vertex. Okay, so we're not going to listen to these directions here, but we're going to plot 5 points on the parabola. They're requiring the vertex, 2 points to the left and 2 points to the right. Then click on graph a function. Okay, let's figure out how to find the vertex first. So the vertex, we're going to use this x equals negative b over 2a. And let me go ahead and write this and write down below like I was doing the last two problems, right below the formula, x squared minus 10x plus 20. Okay, notice it's asking for b's and a's, right? So our a value is going to be whatever coefficients in front of the squared term. So that in this case, it's a 1. And your b value is, of course, going to be whatever's in front of just your x, and that's negative 10. Okay, so let's plug it in. So x is equal to the opposite sign, whatever b is, which for us is negative 10, 2 times whatever a is, 2 times 1. Okay, so we have a negative 10 divided by 2, which would be negative 10 divided by 2 is negative 5. And then 2 negatives together is going to make that just a 5. Okay, so this is 1/2 of your vertex. So x equals 5, we're going to put it right here. Now we're going to have to do a little work to find y. So this is your x, this is your y. Well, this says to us, if you want to know your y, give me an x. Well, we know x is 5. So let's plug that in. So y equals 5 squared minus 10 times 5 plus 20. Okay, so 5 squared is 25, minus 10 times 5 is 50, plus 20. 25 minus 50 is negative 25, plus 20 would give us negative 5. So that's going to be the other half of our vertex there. So let's graph that, 5, negative 5. All right, that's going to be our vertex. Okay, now we have to pick some points. So let's make a chart. 2 points to the left and 2 points to the right. So if this is 5, negative 5, so here's 5 on the x. Let's ask for 4 and maybe 3 to go to the left. And if this is 5, let's ask for 6 and 7 on the right. Okay, I'm going to just draw this so it kind of separates things for me. All right, off we go. We're going to write out this equation 4 times, and each time we write it out, we're going to leave room for the x. So the actual problem is y equals x squared minus 10x plus 20. So x squared minus 10 times x plus 20. So in this case, we're going to put a 3 in for x here and here. We'll do it again, but this time we'll put a 4 in for x. We don't have to do it for the vertex. We already know that. I'm wondering if I'm even going to have a large enough graph to be able to accommodate these points, because I have a feeling they're going to be large. We're about to find out. Okay, 3 squared is 9. Minus 10 times 3 is 30. So we have 9 minus 30 plus 20. All right, let's do that on our calculator here. 9 minus 30 plus 20, -1. Okay, that might we'd be able to graph that one. 4 squared is 16, minus 10 times 4 is 40. So 16 minus 40 plus 20. -4. All right, we probably have a shot at graphing that. Let's try a 6. So 6 squared is 36. Minus 10 times 6 is 60 plus 20. Okay. 36 minus 60 plus 20, -4. And then 7 squared is 49. Minus 70 plus 20. All right, -1. Well, that's convenient for us. I think we can get all of these on our graph. By the way, our A value is 1 and it's positive, so we know this thing is going to face up. Oh, and here is the actual, I think, the graph a function button. So I think this is how you plot your points, and then I think that's what you use on ALEKS to get the points to connect. So over 1, 2, 3, down -1. Over 1, 2, 3, 4, down -4. We have our 5, -5. Over 6, down -4. And over 7, down -1. Okay, so this is going to make a little cute parabola like this. Whee! All right, so hopefully this is helping. You're going to get a lot of practice in ALEKS doing this. Just make sure to take your time and have some patience with yourself. And be careful of order of operations. Okay, I have the last 2 problems to look at here. Find the max or the minimum of a quadratic function. Does the function have a minimum or a maximum? What is the function's minimum or maximum? And where does the minimum or maximum value occur? So remember, if it's facing down, your max is here. If it's facing up, your minimum is there. We know that if A value is positive, it's going to face up and you'll have a minimum. If your A value is negative, it'll face down. It'll have a maximum. So in this case, our A value is 1 and it's positive. So it's going to face up and have a minimum. Okay. Now, the next thing to ask you is what's the function's minimum or maximum value? Okay, well, that is the vertex. I left the answer on here for 4. Let's go find out how they found that. So remember, when you have a function in this format, let's write this out. When you have this little parabola in this format, your vertex, you can find your x value by doing -b over 2a. All right, so let's do, well, what is our a value? Our a value is 1 and our b value is 4. So -4 over 2 times 1, x value equals -4 over 2, x value equals -2. Okay, so where does this thing turn? Where is its vertex? Well, it's going to turn when x is -2, but we need to know the corresponding y value. So we're going to plug this -2 back into this. Now notice it says g of x. You can replace that with y, and you're going to write x squared plus 4 times x plus 8. We have an x value to substitute in, a -2. So -2 squared is 4. 4 times -2 is -8 plus 8. So 4 minus 8 is -4. -4 plus 8, y equals 4. Okay, so when they say what is the function's minimum or maximum value, we know it's a minimum. It happens at the vertex. And let's sketch out what this would look like. So -2 and 4 would be like right there. So we know it faces up, so it's going to look something like that. So the minimum value is going to be the y value right here. So here's x, here's y. Y value right there is 4. That's why they have 4 here for their answer. And then where does the minimum or maximum value occur? X equals -2, right? So it occurs right here when x is -2. And actually, when they write it x equals -2, that's called the axis of symmetry. It's what splits this thing in half. It's actually a vertical line that's kind of imaginary, but it kind of goes just like that. And it splits this parabola into 2 equal halves. Okay, you might be thinking, why am I being tortured with this? Well, because at some point you can use this for actual real life problems. So let's give you one to kind of think about. And then we'll end this video here. You've been very patient. Word problems involving the minimum or maximum of a quadratic function. So here goes. A ball, and I already put the answer on here, but I'll show you how we got that. A ball is thrown vertically upward. After t seconds, its height h in feet is given by the function h of t equals 64t minus 16t squared. After how long will it reach its maximum height? Okay, what is the a value on this thing? Well, it's in front of the squared, so it's -16. So because it's negative, it's going to be a downward facing parabola. Okay, we know the max is going to happen here at the vertex, the turning point. And if you think about it, when you throw a ball, so I'm going to put a person here. I'm terrible with art, so here's my stick person here. So they take a ball, they throw it up in the air, right? And then it's going to come back down and land somewhere. So it's a parabola. They're looking for us to find how long. Well, that's time. Is it going to take to reach its maximum height? Well, we need to find the vertex, right? So I'm going to put this actually on a graph here. This is going to look kind of crazy, but all right. So on your x-axis here, you're at 0 seconds, 1 second, 2 second, 3 second, 4 second, and then your y-axis would be time. Not time, excuse me, height. I should have some caffeine today. I feel like I'm messing up here. Okay. So time is happening here, height is happening there, and our job is to find out, well, how many seconds does it take before this ball hits its maximum height, right? Whatever that might be. So we need to know what x is. Well, we know that x is -b over 2a, right? That's part of finding that vertex. So let's identify our a's and our b's. So a is -16, b is 64. So we're going to put it in this formula. X equals the opposite of b, which is 64, over 2 times a, which is -16. Okay, so x, which is time, is equal to -64 divided by -32. Well, negative divided by negative is going to be a positive. 64 divided by 32 is 2. So x, which is time, is 2 seconds. And the reason I'm using seconds is because they said after t seconds. So that's how they got the 2 seconds. Okay, good luck this week with parabolas. Hope you have some fun. Bye.